Moving on to question 3 now, we have a question here that's looking at the Poisson distribution. So a few different parts to this, which involves basically just looking at probabilities, working at probabilities again, but adjusting the average rate, and then a little bit involving binomial and Poisson here, and then finally doing a hypothesis test. So let's start with part A, which is a nice easy introduction for this question. We've just got to work out a probability. So we're told the average rate of errors is 1.7 for every 100 words. So the question just asks us to find the probability that the secretary makes fewer than 2 errors in the next 100-word piece of work. So if I say X is a Poisson distribution, and obviously my average is just going to be 1.7 because that's for 100 words, we're looking at the next 100-word piece of work. So my average rate stays the same. Now all I've got to do is work out the probability that X is less than 2. Okay, well, if it's less than 2, that's just the same that the probability is X less than or equal to 1. Okay, so when it's strict like this, it's less than 2, and we can say it's less than or equal to 1. Okay, all you got to do now is plug this in on your calculator. If you've got a graphical calculator or a calculator that has a stats function, or you could just use your tables, but what you will get is 0.49324. Or if you round this up, it'll be 0.493. Okay, so that's part A done. Part B is pretty similar. We've just got to adjust the average rate first. So we're told it's for a 250-word article. Well, if we're looking at it for 100 words, we've now got to go to 250 words. I've got to multiply by 2.5. So if I say it's Y for this one, so Y is a Poisson. Well, my new average rate is going to be 1.7 times 2.5, which if you do on your calculator, so this is for part B, what you'll get is 4.25. So that's 4.25. Now, all I've got to do is work out that it's exactly 5 errors using this average rate here, so that's probably X equals to 5. Again, just use your calculator, plug this in onto your calculator, and you'll get 0.165. Okay, so that's part B done. Let's have a look at part C now. So there's a bit more going on here. Basically, there's 2 options that I give them. Scheme A, the secretary will receive the bonus if more than 10 of the 40 pieces of work contain no errors. And then scheme B, the bonus is awarded if the total number of errors in all 40 pieces of work is fewer than 56. We have to show the calculations clearly and explain which bonus scheme we would advise. So we're going to have to consider each one separately. Now, the easier one to work with is scheme B first. So let's just do scheme B. So scheme B. Well, for scheme B, what it's saying is that if the probability of, so let's call it B. So the probability of B is less than 56. Like it's saying here, it's fewer than 56, then we're all good. That's what we want. So how do we find the probability that B is less than 56? Well, that would be the probability that B is less than or equal to 55. But we've got to be careful here. What distribution are we going to be using? Well, we're going to say B. Now, because it's just one continuous look at this, so it's just all 40 pieces of work, we're not looking at a certain proportion of the 40, like scheme A does. Because it's a continuous amount, it's all of them, then we can just use a Poisson still. So this is a Poisson distribution. Now, the average rate, just be careful here, because there is 40 lots of pieces of work, and each piece of work is 100. Well, what I'm going to have to do here is 40 times 1.7, so 40 times 1.7. If you do this on your calculator, what you'll get is, this is 68, so my average rate now is 68. Well, all you've got to do, put this on your calculator. So this is a good thing about this question, there's a lot of calculator work. As long as you've got the graphical calculator, it makes this nice and easy. And if you put this on your calculator, you get 0.0611. Okay, so that's a 0, 0.0611. So that's scheme B. So we've got the probability there. Let's get scheme A now and work out the probability for that. So scheme A, well, what this is saying is they only receive the bonus if more than 10 of the 40 pieces of work contain no errors. Well, first, let's consider what happens with one piece. So this would still be a Poisson, So for example, using 1.7, so using lambda equals 1.7, if we consider one case, well, that would be the probability that x is equal to 0. What would this probability be? Well, this would be 0.1827 using lambda equals 1.7. So it's still a Poisson at this point. But because we want a proportion of the 40, so we're looking at more than 10 of the 40 pieces of work contain no error, we've now got to model this using a binomial distribution, okay? So we need binomial. So what letters have we used? I can't remember what we used for A and B for this question, but I'm just going to use X again. So if I've already used X, don't use X like I have. But I'm going to say X is distributed binomially. What's my total sample size? Well, it's going to be 40 because we've got 40 pieces of work. My probability is this probability here when X is equal to 0. So 0.1827. And now all we're doing is looking when more than 10. So more than 10 of the 40 pieces of work contain no errors. So probably that X is greater than 10. Well, remember, if you're doing greater than 10, in this case, this is the same as 1 minus the probability that X is less than or equal to 10. So, do this bit separately. This probability that X is less than or equal to 10. If you put that in your calculator, that would be 0.90039. And then if you do this on your calculator, what you'll get is 0.0996. Okay. Well, which of these probabilities is better? Well, this would be 6.11. This would be 9.96. So therefore, due to that, scheme A is better. So therefore, choose scheme A. Scheme A. So that's, I can't spell scheme A. There we go. So that's better probability. So we choose scheme A. And then finally, for part D, it's just a hypothesis test using a 5% level of significance. And what are we told? So, following the bonus scheme, randomly selects a single 500-word piece of work from the segregated test if there is any evidence that the errors have decreased. Okay, so that's the important bit. They've decreased. So this tells us what kind of tail this test is. So whether it's a one-tailed or two-tailed test. So first off, we're going to check whether lambda is equal to 1.7. That's going to be my H0. And my H1, because we're testing whether the errors have decreased, that means lambda will be less than 1.7. So less than 1.7. So less than 1.7 and then equal to 1.7. So them are my two hypotheses. Now it's looking at 500 words. So 500 words. So we need to adjust the average rate. So what I'm going to do now is times it by 5. To get from 100 to 500, I've got to times it by 5. Do the same with the average rate. So therefore, lambda is equal to 1.7 times 5, which is equal to 8.5. So in this case, if I call it Z, Z is a Poisson distribution with an average rate of 8.5. Now for this test, we're only being asked to find the critical region. So to find the critical region, you've just got to find the first value, the first significant value, where it's less than the significance level here. So this is 0.05. Okay, so you need to use your formula book for this. So you go onto the page with the Poisson values. Make sure you're looking where lambda is equal to 8.5. And what you want is the first value where it's less than 0.05. Well, if you look on the table, what you'll see is that the probability that x is less than or equal to 4. In fact, sorry, it should be z in this case. So z is less than or equal to 4. What you get is 0.0744. And that's above it, so we can't have that. But the next one down here, z less than or equal to 3. What you get is 0.031. And because 0.031 is smaller than 0.05, what this means is that the first significant value is x equals 3. So therefore, critical region is x less than or equal to 3. And there we have it. So that's question 3 fully complete.